get turned. I get rowdy, backwood full of some of the loudest. I'm fucked up, I get wasted. That's $100.
Okay, so now we're going to prove that the square root of c plus square root of c plus 2 equals 3 has a solution using the intermediate value theorem. Okay, so here we're just given an equation, basically, like an f of c already. So we can rewrite this as f of x, because we're going to be using c's later on. So f of x is equal to square root of x plus square root of x plus 2. Okay, so we're going to say that this basically, so what we want to find is that f of x takes on or has the value of 3 somewhere. It doesn't give us an interval, so we can make up our own. Okay, so at some point this function hits the y value of 3. Okay, so what I'm going to do is kind of pick points. So we'll see. So this is the m value that we want to hit, right? This is the m we want to hit with our interval, somewhere on our interval that we create. So the first thing I'm going to do is say, okay, what happens when x equals 0? This is kind of just a shot in the dark, but we're going to do f of 0 is equal to, I always like doing zeros because they're easy to plug in, right? So square root of 0 plus square root of 0 plus 2. So this is going to have the value of 2, which is about 1.41. Okay, so we know that. So that's below 3. So now we want to find an x value that makes our f of that value greater than 3. Okay, so now let's choose something kind of higher. So we'll choose a 7, just because I like 7s. Lucky 7. So f of 7 is equal to, if we plug in a 7 here, square root of 7 plus square root of 7 plus 2. So that's equal to 7 plus square root of 9 is a 3. Okay, so here we see that we have 3 plus another almost 3, right? So this is going to be greater, this is definitely greater than 3. So which is greater than 3, and our 1.41 was less than 3. Okay, so at this point, what we're going to do, so I'll write that down. So 3 is greater than 1.41, which was, so 1.41, and then less than 3 plus square root of 7, because that's a positive square root. So this, it turns out that 3 is in between our f of 0 and our f of 7. Okay, so what can we do with this? So basically, what we're going to do is make our conclusion, right? So a lot of it is how you write your conclusion, okay? So I'll continue this on the next slide. So what we can say, so in this one I'll say by the intermediate value theorem, since f of x is equal to, so I'll just rewrite the function here. So I'm just going to state the function. Since this is continuous, and again it is continuous, this one is continuous in particular because it's the addition of two continuous functions. Anything when you have a root of something, in this case it's square root, it's going to be a continuous function. So is continuous on 0 to 7, because remember this was the x range that I picked, the 0 first and then the 7. And since our f of 0 was equal to the square root of 2, and f of 7 was equal to 3 plus the square root of 7, there exists, don't worry, you guys are going to get really good at writing all of this, like our conclusion from the intermediate value theorem. It's going to kind of more or less be like a plug and chug, like you just plug in the function that you got, plug in the interval, plug in the values of the endpoints, and etc., etc. So there exists a at least one value c that is, well, in the interval, in the open interval 0 to 7. This means contained in, or in, such that our f of c is equal to 3. Okay? And then, so to answer the question directly, so there is a solution to the original equation that we were given, to square root of c plus 2 is equal to 3. Okay? Alright, and that was an example of a problem that we solved, not asking directly to show like what the intermediate value theorem is, not directly to apply it, but to kind of solve a little bit something different, right? To show that there's a solution to this thing.
House popping like a frat house. Keep 16s like a verse, nigga. Codeine got me leaning in reverse, nigga.